Sine law applications, question 13. Two ships P and Q are 65 km apart, where ship Q is east 15 degrees north of ship P. Both ships are headed towards Raleigh Harbour R. Ship P sails in the direction south 40 degrees east and ship Q sails in the direction of west 55 degrees south. Determine the distance each ship must travel to reach Raleigh Harbour. Round it to the tenth of a kilometer. Now in this question you need to figure out where the ships are and then make a neat and clean sketch. And that is probably the toughest part of this problem, right? Once you have your sketch, things will ease out, right? So let's start with ship P, because you say two ships P and Q are 65 kilometers apart, so we know distance between them, where ship Q is east 15 degrees north. So let's start with P and then figure out what location is Q on. So let's say that is the location of P, right? So from here, Q is east 15 degrees. So from east 15 degrees north. That means this is your east, right? So from here, 15 degrees north, like this. Do you see that? And 65 kilometers away. So let's make a line from here, say like this. Like this. Do you see? Where that small angle with the horizontal is 15 degrees. That is what it is, right? And let's assume that it reaches that point is Q. Let's make a coordinate here. So what we have here is that we have the ship P here and the ship Q here, correct? So that is from east 15 degrees north. So this is your east, from east 15 degrees north. You travel from P to Q and the distance between them is 65. So this distance is 65. I'm not writing units at present, kilometers. Now, both ships are headed towards Raleigh Harbour R. Ship P sails in the direction south 40 degrees east. So from P it is 40 degrees east from south. So let's try to draw where is this. South is this, and from south 40 degrees east. So this is like kind of midway. So let's say around this direction, right? So from south 40 degrees east. So we'll draw a line from here saying, well, that is kind of a line it sails, correct? So this is from P. Now read again. Ship P sails in the direction south 40 degrees east and ship Q sails in the direction west 55 degrees south. So that is south for Q and west is this direction. Now it says 55 degrees. And let's assume that that is from south 55 degrees west is kind of here, right? So from here let's assume that. And so it says like kind of like this. Do you see that? So that is, now we can label our diagram. So first let's go back to P, where ship P sails in the direction from south 40 degrees east. So this is from south 40 degrees. So this is 40 degrees for you, right? And as far as Q is concerned, it sails in direction from west. This is your west, and from west 55 degrees. So this from here to here is 55 degrees. Do you see that? So from west 55 degrees. So whatever I've drawn, that angle, that big angle, is 55 degrees. So from west 55 degrees towards south. Correct? So that is the diagram which we have come up with, and that point is R, the harbor R. Correct? Now what we need to find is determine the distance each ship must travel to reach Raleigh Harbour. So PR and QR is what we need to find. Now let's try to figure out. We know this side, so important for us is to find this angle. So to find this angle, what can we do? So we have to find the rest of the angles, correct? Now we can find this like this. If you consider these two lines are parallel, these are both horizontal lines, correct? And now if you say this is your 15 degrees, that means that is 15 degrees and this angle should be 55 minus 15. Do you see that? So this angle should be 40 degrees. Do you understand? This angle should be 40 degrees. So angle PQR, so we say angle PQR equals to 55 minus 15 degrees. So 15 is the corresponding angle, right? 15 degrees. So that is 40 degrees for us. So we found one angle, correct? Now let's go to point P. Now this is 40, so that is 90 in all, right? This itself is a right triangle. So therefore 40 minus, from 90 if you take away 40 you get 50. So this angle is 50 for us. So angle QPR is equals to 50 plus 15, right? 50 degrees plus 15 degrees, which gives us 65 degrees, right? So we have 65 degrees here, and therefore angle PRQ is equals to 180. 180 is the sum of all the three minus 65 degrees and minus 40 degrees, and that gives us 180 minus 65 minus 40. 75 degrees is what we get. So we get 75 degrees, and so this angle is 75 degrees from us. So that is kind of most important calculation which you need to do, right? So you got all the angles and you got one combination of opposite side and an angle. So you can find now the distance PR and QR, correct? So PR for you is how much? We say PR, you can do this calculation by yourself now. PR over, so I'll write down the formula. PR over this side opposite to PR is 40. Sine of 40 is equal to what is given to us? 65 opposite to 75, right? So you get 65 over sine of 75, right? Sine of 75. And this is equals to QR, which you need to find, right? Over the angle opposite to QR is 65. Sine of 65, correct? So you can solve this for PR and QR and write down your answer, correct? So that is how you're going to solve this problem, right? So from here, what is PR equals to? PR will be 65. Let me write down. So you do your calculations, and I'm just writing down answers here, using some space here to write down my answers. So let me use the other ink. So we have PR is equals to 65 divided by sine of 75 times, let's do it again. So it is 65 divided by sine of 75 equals to times sine of 40, which gives me 43.255, round to 10th of kilometers, so we can write 43.3. And QR will be equal to 65 divided by sine of 75 times sine of 65, which is 60.98. 60.98 can be written as 61.0. So that is our answer, rounded to 10th of a kilometer, correct? So we get so many kilometers.